Hello, my dear energetic, joshful students. The journey was exciting, it was fun, and we have come this far. And this is the time that we do the final lap. This is when we do the PYQs. The exam is on 24th of November, and we are in the mode of revision. And today I'm going to talk about four questions in part 4 series of 2022 PYQs. Now, my name is Bhavdeep Sethi, and with a passion of physics teaching, I have been converting a lot of physics haters into physics lovers. And I always say physics is learned with the nature. Go out in nature, play with nature, and you will learn physics. Now, obviously, you should never expect spoon feeding from any of my classes. I'm not going to give you solutions here. I am going to give you the question, I'm going to teach you the concept, and it is expected that you solve them yourself. Now, first things first, obviously, the exam is on November 24th, few days to go. And this is when you do the final lap. You do a lot of practice questions right now. Now, we'll jump into this. So, the very first question here is 16th question in 2022 paper. So, it says a convex lens is held 45 centimeters above the bottom of an empty tank. The image of the point object is formed 36 centimeters above the lens. Now a liquid is poured into the tank up to a height of 40 centimeters above the bottom. It is found that the distance of image of the same point object at the bottom of the tank is 60 centimeters above the lens. We have to find the refractive index. So if I were to draw a sketch of what's going on here, what is going on here is there is something here. So let's first draw a tank. So I don't know if this looks like a tank to you. So the tank is 45 centimeters deep, right? That's 45 centimeters right here. And they say you keep a lens, so assuming it's 45 centimeter, whatever, the distance is 45, and they're saying the image is formed 36 centimeters above that. Cool, great, okay. Now they say if you were to fill this up to a height of or depth of 40 centimeters, they are saying that now the image is formed at a height of 60 centimeters. So you're bringing the object closer because the virtual depth will reduce. But first things first, I know originally the object was 45 centimeters, their image was 36 centimeters. Very quickly, I can find the focal length here. So the focal length is 1 by f is equal to 1 by v minus 1 by u. So 1 by f is equal to 1 by v. 1 by v is positive 36. So 1 by 36 minus 1 by u, but that u itself is negative 45, so plus 1 by 45. Now to find the LCM, I'll see 9 is common here, so 36 times 5 is 180. So this is 5 plus 4, 9 by 180. So I'm getting the focal length as positive 20 centimeters. This does not change with the fact that you're filling the water there. That's okay. Now, when you fill the water, this looks like the image virtually has risen up. And that's why the object virtually has risen up. So the image is going further. So first see where is the object visible to this lens. Lens is making the image at 60 centimeter. That means 1 by 20 is equal to 1 by 60 minus 1 by u. So I don't know where the lens is looking for the object. It's somewhere here, but that something is given by this u. So you bring this u here, you bring that there. So 1 by u is equal to 1 by 60 minus 1 by 20. LCM is 60. This is 1 minus 3, so minus 30. So u is coming out to be negative 30. So it looks like that the lens can see the object at 30 centimeters distance, because when the object is at 30 centimeter, the image is at 60. But wait, that's not your answer final. You want to find the refractive index. So the point is, see, think about it. This whole thing was 45 centimeters and they have filled the water to 40 centimeters. So there is a gap of 5 centimeters here, isn't it? There's a gap of 5 centimeters there. That air gap does not change. So if the total were to be 30, that means the water depth, which is 40 centimeter, this is not 45, this is 40, because they filled up to a height of 40. So this 40 is shrinking to 25. Where did that 25 come from? The total distance of object is 30, air gap is 5, so 25 more is the water depth. As in the depth of the tank here, the water was 40, but it is visible as 25. So the virtual depth is the original depth divided by refractive index. So refractive index is 40 by 25, which is 1.6, and that is your answer. Okay, let's move on to the next question here. In a Young's double slit experiment, distance between slits is 1 millimeter. The wavelength of the light is 600 nanometers, and the distance of screen from the slit is 1 meter. Very beautiful number out there. Thank you for that. The minimum distance between the 2 points on the screen where the intensity is less than, or not less than, it's exactly 75% of the maximum intensity. Assume both the power sources are equal. They have made it so easy for us. If the power sources are equal and the intensity of each is I naught, then the maximum intensity is 4 I naught. So if this were the screen, at the center it would be 4 I naught. And there would be more maximas with 4 I naught. But they're saying, okay, find the distance between where it is 75% of this. 75% of this is 3 I naught. So where is it 3 I naught? This 3 I naught and this 3 I naught. So they want to find the distance between those two. It's very easy question. You know, this is 3 I naught. So how much should be the phase difference here? So we know the intensity which is required is 3 I naught. This 3 I naught should be equal to the intensity 1, which is I naught, plus intensity 2, which is I naught, plus 2 times intensity naught times cos of the phase difference. This subtracts here, makes it I naught. I naught gets cancelled out. 1 by 2 is cos theta. So theta is pi by 3. So I know theta, the phase difference, or you can say delta phi or whatever, is pi by 3. Awesome. Let's convert it to the path difference because you're talking about distances here. So this theta or the delta phi, whatever you want to call it, is same as 2 pi by lambda times of delta x. Isn't this, the conversion of this here? That is given to me as pi by 3. So pi crosses out, delta x is lambda by 6. So that path difference is lambda by 6. So let's write it down. So delta x is lambda by 6. Now, if you've done the wave optics, you definitely know the easy relationships there. So this y, so let's call this y, this y over d is going to be equal to this delta x by d. I'm just using the simple geometry out there. There's no fancy thing here. So this y is equal to delta x d by d, but delta x is lambda by 6. So y should be equal to lambda times d by 6d. Perfect. Awesome. Awesome. This D is given as 1 meter. Thank you for that. Lambda is 600 nanometers. So 600 times 10 to the power minus 9 divided by 6 times D. Now, how much is the distance between those two? 1 millimeter. So that's 10 to the power minus 3. And that crosses out to make it 10 to the power minus 6, 6 cross out. So it's 0.1 millimeter. So this is zero point 0.1 millimeter, but they're saying what is the distance here? That is 0.2 millimeters. And this is one of the frequently made mistakes in the exams. Please do not make that. Many students see this answer as 0.1 and there is 0.1. No, you have to read the question properly and see what is being asked there. Let's move on to the next question. Very beautiful question, very easy question, can be done in 1 or 2 steps. A ball is projected from horizontal ground. It attains a maximum height h on its projectile path and thereafter strikes a stationary smooth vertical wall and falls on the ground. So the ball is going, it hits a wall and falls on the ground vertically below the point of maximum height. This makes the question easy, otherwise it would have been challenging. Assume the collision with the wall to be perfectly elastic. The height of the point on the wall where the ball strikes is. Okay, the journey would have been, I'll rather use white color here. So the journey would have been something like this. Okay, but they said, oh, there is a wall there and the ball strikes right below the maximum height. Okay, so in order to do that, I mean, if the collision is elastic, see, if there is a wall here, there is no force in the vertical direction, so nothing has changed in the vertical direction. There's a force backwards. If the collision is elastic, the ball is going with some velocity, it has to return back with the same velocity. Right, elastic collision, the wall is not moving, virtually not moving, because our walls here, you can see the beautiful symmetry out there that it is going to be a mirror image here. It is going to be a mirror image here. So this is the mirror image of this, because see, think about it, this velocity has not changed, this velocity has not changed. So this is a beautiful mirror image of that. So that means these two distances are equal. That means this is, the whole thing was range r by 2, so r by 4, r by 4. Wow. So basically the wall is situated at 3r by 4, and that is the beauty of the simplicity of this question. Now you can do it two ways. One way would be you do from the first principles. That is what I like to do. I always say never memorize the equations or formulae. Do it from the first principles. You can definitely do that. It will be done in 5 or 6 steps. But by chance, if you know the formula of the projectile trajectory, it is x times of tan theta times 1 minus x over r. Perfect. And that makes the things easy because this x is 3r by 4. So let's put that. So 3r by 4 times tan theta. How much is tan theta? So 4h by r. 4h by r. Perfect. And then 1 minus x by r. X by r would be 3 by 4 because x is 3r by 4. So minus 3 by 4. And then we cross out a few things here. We cross out this 4 and this 4. Then we can cross out this r and this r. Now 1 minus 3 by 4 is 1 by 4. So that is 3h by 4, and that is your answer. It is so easy. If you look, if you're able to find the symmetry here, if you're able to visualize that symmetry, as in there is a mirror image over there. Again, a very beautiful question. When I say beautiful, I mean very easy. Just have to know some concepts. As shown in the figure, a block of mass m is projected from a wall. So it is projected here with a velocity of 2v naught on a rough surface. This is rough surface with a constant sliding friction to hit the wall B with velocity v naught. So it starts at 2v naught, stops there with v naught, right? Now they're saying with what velocity the same mass m should be projected to hit the wall B with the same velocity v naught if the surface is now moving up with acceleration 4g. Wow. So if something was accelerated up, that means there is a bigger normal force. Bigger normal force means more friction. More friction means more retardation. But I would still want to have the same velocity, then I have to project it with a bigger velocity. Okay, cool. Very, very easy. So first of all, let's see where is the friction playing the role here. So if you think about it, so there's a body here. It experiences a friction force backwards. How much is it? It is mu times the normal force. If it was not accelerated in vertical direction, the normal force would be mg. So you would say mu mg is the friction force, and that is equal to mass times the retardation. So retardation was mu g to start with. But then if you accelerate up with 4 times the gravity, now very easy. I mean, you can do it verbally or you can make the free body diagrams, write the equation. It's your choice. But if it was not accelerating, the normal force is mg. But if you want to accelerate up with 4g, then you need extra 4 mg. to provide that acceleration. So total of normal force will be 5 mg to balance out the things there, and 4 mg to accelerate up with 4g. So total of 5 mg. So that means the new acceleration would be the 5 times of this, 5 times of the original acceleration, or let's call it retardation. So when the thing was not accelerating up or down, there was certain retardation. But as soon as you accelerate up with 4g, there is a 5 times retardation now. So let's start writing equations. So the original case would be the final velocity square minus the original velocity square, which is 2v naught. So that makes us 4v naught square is equal to 2 times the retardation, let's call it a, 2a d. The d is the distance over there. So that becomes 3. So the acceleration there is minus of 3v naught square by 2d. This was the original retardation. Now the new retardation would be 5 times, as in negative 15 v naught square by 2d. I still want the velocity to be v naught when it reaches there. So what is the initial velocity? Let's find out. So the final velocity should not change. Initial velocity I have to find, that should be equal to 2 times acceleration. Acceleration is negative of 15 v naught square by 2d, that's the acceleration or retardation, times d. D is still d. So let's cross out things here. 2 crosses out here, d crosses out here. So this negative 15 v naught square comes here and becomes positive. So this is 16 v naught square is equal to u square. So u square is 4 times of the original velocity. That is your answer. See, in the all the 4 questions we solved today, you would have seen we solved it in 1 or 2 lines, because these are the type of questions where you can go a lot of in depth, keep going, thinking, and then solving it in 10, 15 steps. But there is another option. You sit back, relax, not relax as an exam, you don't have that much of time. But what I mean is look at the bigger picture here, what is going on. And with that, you can solve it much easier way. Okay, if this was logical, I would highly encourage you to please like, subscribe to this channel, and also spread out the word about it. Please tell your friends about it. Now, and since we are doing the PYQs, I have launched, this is a new news for you, that I would be coming here to solve a lot of PYQs, but many students have requested me to launch a batch for the achievers last mile preparation. See, the journey has been so beautiful so far, but every journey, the last mile is the most important. This is where the champions are made. So we are launching the batch NSEP Achievers, the final lap, and the classes are going to start on 8th of October, and they go on till 23rd of November, because 24th November is the final exam, NSCP exam. 23rd you will have the final test. You will have classes on Tuesdays and Thursdays 6 to 7:30 p.m. But the last week there are 5 classes: Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday is your test, and the number of classes 15, and then the price is 2222. But you can use the same coupon that you have been using so far for BS Pro 1. Bhavdeep said he Pro 1, digit is 1, and you get 10% discount, so the price will only be 1999. It's open for 10th, 11th, and 12th graders. You will get assignment after each test. There are assignment after each class, and there are total of 6 tests out there. So 5 full test and 5 part test and 1 full test. I'm so excited. I mean, there's a lot of slip of tongue happening today because I'm so excited about this batch. Looking forward to it. So you can use the discount code, obviously. And if you are targeting next year's NSCP, then we have the full version of the physics mastery course, where we have 5 modules, and we go a little slow and steady kind of pace there. We go a lot of in depth there. So the course I was talking about earlier, this is more like a revision thing where we do a lot of questions for the last minute practice. But the course that I'm talking about here is more about like going in depth into the concepts. Two different things. So there are 5 modules here. So the links for all these are below in the comment box here, the description box, I mean. So you can click on those. The coupon codes will all automatically be applied. And I look forward to see you in one of these classes. So thank you so much, my dear students. Looking forward to see you in the class. Take care. Bye bye.